gamers, and welcome to another video. Today it's Advent of Code. It's that time of year again, and I really want to see your solutions, so leave those in the comment section down below. If you want to support the channel, there is a link in the description to different affiliates where you can get great deals on things, and there's also a donation link if you want to donate a coffee to me in order to improve the quality of the channel. Day 4. Ceres search. Look like the chief is not here. Next. One of the historians pulls out the device and pushes the only button on it. After a brief flash, you recognize the interior of Ceres monitoring station. As the search for the chief continues, a small elf who lives on the station tugs on your shirt. She'd like to know if you could help her with a word search. Your puzzle input. She only has to find the word Xmas. The word search allows for words horizontal, vertical, diagonal, written backwards, or even overlapping words. It's a little unusual, though, as you don't merely need to find the instance of Xmas, you need to find all of them. Here are a few ways Xmas might appear. Irrelevant characters are replaced by a dot. Yes? The actual word search will be full of letters instead, for example. In this word search, Xmas occurs 19 times. Here is the same word search again, but the letters not involved in any Xmas has been replaced with dots. Take a look at Little Elf's word search. How many times does Xmas appear? Yes, and I've already solved this. I've been to Ceres in Switzerland for a couple of days, so I solved them over there, and I'm just gonna go through my solutions today. So first off, we have this main function. We get our lines in here for day 4. Then I created a grid of numbers, and the grid of numbers should be line size in the Y position, and then I created a J, which I could increment for each line, and a width, which is a width of the line. So if the line is not blank, get the width of the line and create a grid line, and then I will go through each of these grid lines with an I, so that's the other incrementer here, and for each character, so I split the line into characters. I check if it's an X, I put it as a 1, M as a 2, A as a 3, and S as a 4. So I create a grid where each number is incremented in the word order. Then I have this little counter down here that counts how many instances I find. So I go through Y on the grid and X on the grid, and then I have check all directions. It's a function. It's actually just checking one of them. And then print out count here. So my first thought was that this function should be able to check all directions, but I then realized that I need to step in the same direction for all of them. So I start in one direction, and then I need to check the full length of that direction recursively. So this is the first. I check XY in the grid, and then I have the direction here, which is an dx, so a deviation, the difference in x and y in the direction. So this would be straight to the left, and nothing on the y-axis. And then the value I start at is 1. So we looked up here, we start at having an x. So we will check if we have an x, and then we will increase in that direction. And if we find something, we will add to our count. So let's check this function then. We get all this in here. The first thing we need to check, of course, is that we aren't outside of the actual map. So first off, if x or y is less than 0, we stop. If they are longer than the actual length of the grid, we stop. And then we will check if this current value that we are standing on now is the value that we sent in. So in the first case, a 1. And if it's not, then it's also false, because we didn't find what we were expecting in this position. And if the value of the currently checked is 4, then we know that we're done, because we have spelled out the whole word. And then we will continue to checking in this direction recursively. So we send in the grid, we change in the x value with the deviation and the y value with the deviation, the deviation for this direction, and then the value incremented. And if we find all the 4 values in that direction, we return true. Other ones, we return false. So a pretty simple implementation with regression to find this. Next, part 2. The elf looks quizzically at you. Did you misunderstand the assignment? Looking for the instructions, you flip the word search and find that this isn't actually an Xmas puzzle. It's an X-mass puzzle, in which you are supposed to find mass in an X shape. One way to achieve this is like this, and we have an example here. The irrelevant characters has again been replaced with dots in the above diagram, with X and mass been written forwards and backwards. Here are an example from before, but all the time Xmas have been instead. In this example, Xmas occurs 9 times. Flip the word search around and the instruction back and the word search side. How many times does Xmas appear? So my solution to this was pretty simple. I continue with a similar implementation that I had. So I have this first reading part, which is just the same. So I get the numbers in here. And then I go through the whole grid and I check all directions here again. And what I want to start with is the value 3, because if I find an A, that's the center of the mass. So I want to find all 3s, and if they have a certain condition, then I will count them. So let's look at my function here. The first things up here are exactly the same. So I'm looking at the different that I'm not outside and that I found the correct value. Then I want to look at the outside. So here we have an example where the M's are in the top and the S's are in the bottom. And then I go through and create this little grid. So I check the upper left, upper right, lower left and lower right. And then I put in the numbers here, 2, 2, 4, 4. And then we have another example here where we have 4, 4, 2, 2. And then we have an example with 2, 2, 4, 4. And the last example is 4, 4, 2, 2. So writing this example down, so I knew what to look for, which character were the correct ones I looked for, and commenting it down so I could keep track on it, made it much easier to think about and also write it down. So this was a pretty quick one, and solved it really late in the night. So solving it in a very static way was nice. 1 o'clock in the night after the conference. But I got it to work, and this was my solution. I really like to see your solutions. Leave those in the comment section down below. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.